All right, so these are the notes for inverses. So first off, definition for inverses are going to be functions that undo each other. All right, so our first thing is, it says for tables and ordered pairs. So for a function f, the inverse is denoted as f to the negative 1 power. Now, we don't actually read this as f to the negative 1 power. It actually is read as the inverse of f. So this one is read as, for a function f, the inverse is denoted as the inverse of f. So f to the negative 1 power is read as the inverse of f. All right, so when we're talking about tables and ordered pairs, it says, to create the inverse of a function, simply swap the x and the y values. So if you take a look at our original function, we know this is our original one because there's no negative 1 power, and this right here has negative 1, so that's our inverse. So currently, our x values are 1, 2, 3. Our y values are 4, negative 5, and positive 6. So all we have to do is just swap our x and y values. So our y values, 4, negative 5, 6, become our new x values. And our x value becomes our new y values. And you can see we switch the x's and the y's. Now, one question that you'll usually get is the inverse a function? And in this case, all we're going to look at is the x values, right? So if we look at the x values, we have 4, negative 5, and positive 6. None of them repeat, so yes, it is a function. And if you want to look at the original one, 1, 2, 3, we can tell that one is also a function because the x values do not repeat. But this one says, is the inverse a function? 4, negative 5, 6 do not repeat, and yes, it is an inverse because of that. Now, when we're talking about ordered pairs, so we have G is M, N, P, Q, and U, V, and now we're looking for the inverse of G. Now, really quickly, this is x and this is y, so x, y, x, y. So once again, to get the inverse, all we do is switch the x and y, or we swap places. So mn becomes n, m. pq becomes qp, and then uv becomes vu. And again, we can check if it's an inverse just by looking at the new x value. So n, q, and v, now those repeat, so the inverse is a function. All right, now when we get to graphs, it says to create the inverse of a function based on a graph, blank the points of the original graph. So what we're going to do is we're going to plot the points of the original graph, blank the x and y values for each point to create new points. So we're going to switch or swap, and then blank the points, making sure to draw the inverse reflecting over the y equals x line. And then I guess graph the points or plot the points. Your choice on which word you want to use. But graph the points, making sure to draw the inverse. Okay, so first off, you notice they have the y equals x line right here. So the inverse graphically should reflect across that line. So there's two ways to do this. I'm going to go ahead and show you here. The first way that I do it is I take my original points. So I'll do this right here. We'll call this F. So here's x and here's y, and I'm just going to take these points and do them. So we have negative 4, and let's call that negative 4. I think the points are off a little bit. Negative 4. It looks like this should have been at negative 5. So negative 4, negative 5. Negative 2, 2. And then we have, there should be a point right here at 2, 0. And then we have 4, 5. All right, so if I wanted to find the inverse of this function, all I would have to actually do is just switch x and y. So the inverse, we just take our x and y values and we switch them. So my negative 5 becomes my first x value, then 2, then 0, then 5. And then my y values now become negative 4, negative 2, 2, and 4. Now we'll go ahead and graph these. So negative 5, negative 1, 2, 3, 4. Then we have 2, negative 2. So 1, 2, negative 2, 0, negative 2. Sorry, that should be a positive 2. Sorry about that. 0, 2. And then our last one, 5, 4. So 5, and then 1, 2, 3, 4. And then we're going to connect our dots. And there's our inverse. And we can see that it's actually flipped across the line y equals x. Now, another way to make sure that this is actually working, you can actually count the distance that each one is from that diagonal line, they should be the same. So you notice that this purple line, this purple dot is half diagonal square away from the other part, so half it. This one is also half. So this one here, I can count 1, 2 away. If I count 2 to the other side, 1, 2, they're the same distance away. This one is 1, and this one is also 1. This one's halfway, this one's halfway. So you can see they count up that way as well. All right, now the last thing we'll talk about are the equations. So for the equations, it says to swap x and y, and then you solve for y, and it is actually that quick. So f of x is really y, so we're going to write, change this to blue, f of x, we're going to change that to y, equals 2x plus 5. Now, first step says swap x and y. You don't swap numbers, you only switch the letters. So x equals 2y plus 5. So notice I didn't move the 2, it was just the x and y switch places. Now from here you solve for y, and that's going to be your inverse. So to solve for y, the first thing I'm going to do is subtract by 5 on both sides. So x minus 5 equals 2y. Then I'm going to divide each one by 2 individually. And we get y equals x over 2, or 1/2 x, minus 5/2. And now, since this is the inverse, we're going to put the -1 to show that it's the inverse. So the inverse of y is x over 2 minus 5/2. Another way you could have written it was as the inverse of y is 1/2 of x minus 5/2. Now, the last thing you could have done, instead of dividing them individually by 2, you could have actually divided the whole thing by 2. So you would have had x minus 5 divided by 2. I actually prefer it the middle way, but this way would be acceptable if it was an open-ended question. If it was multiple choice, it could be written in either one of these forms. So just make sure you are familiar with how to get all three. Now, the composition of functions, we're going to cover that later on because we haven't done compositions yet. So let's take a look at some of the examples we have that should help you to complete your homework. All right, so again, it says find the inverse of each relation and determine whether it is a function, yes or no. So again, in order, when we're given ordered pairs, all we have to do is just swap the x and y. So -3, 5 becomes 5, comma, -3. 6, 7 becomes 7, 6. 6, -4 becomes -4, 6. And I'm adding the braces and the commas, and there's my answer there. Now, is the inverse a function? Well, 5, 7, and -4 did not repeat, so is it a function? Yes, it is a function. All right, let's take a look at the next one. So again, we're going to switch it. 1, 3 becomes 3, 1. 8, -5, 8 becomes 8, -5. 7, 3 becomes 3, 7. And 9, -6 becomes -6, 9. So there's my inverse. We're going to look to see if any x value, my new x values repeat. And right here, we see these 3's repeat. And we can automatically assume, no, it's not a function. No, it is not a function. Okay, for the next one. It says, sketch the graph of the inverse for each relation. So let's go ahead and take this first one. Let's go and use purple here. So I'm going to take these dots. We'll call this F. And then we'll call this the inverse. But you can actually see, I don't really need to. So you have y, and then you have the inverse of y. So this shows right here that it's the inverse. But okay, so let's go into this. This dot right here is at -1, -2, -3. Then we have 1, 2, 3, 4, 5, 6, 7. So there's my first point. -2, -5, 0, -1, 1, 1. And then 1, 2, 3, and then 1, 2, 3, 4, 5. All right, so there's my original function. And for my inverse of that one, we're just going to switch the x and the y values. So my new x's become -7, -5, -1, 1, and 5. My new y values are -3, 2, 0, 1, and 3. We're going to take this table, we're going to graph it over here. So -7, 1, 2, 3, 4, 5, 6, 7, and -3. So there's my first dot. -5, positive, should have been -2. So don't forget signs like that because it will throw the graph off. -1, 0, 1, 1, and 5, 3. And we'll make our graph here. There we go. And just to prove that it is a reflection across that line, y equals x, I'm going to go ahead and draw that in there so you can see what it looks like. And there you go. And you can see the blue line is reflected across, or the blue line is a reflection of the black line across the line y equals x. All right, we have a parabola now. Same thing. This will be our original function. So I have -1, -2, so -3. Then we have -2, 0. We have 2 and 3. Let's go and get these y values. So 1, 2, 3, 4, 5. So -3, 5 is my first point. -2, 0, 0, -3, 2, 0, and 3, 5. Now for the inverse, we're going to flip them. So here are my new x values, 5, 0, -3, 0, and 5. New y values, -3, -2, 0, 2, and 3. So let's go ahead and graph these points here. And this will be my inverse. So we'll start at 5, 1, 2, 3, 4, 5, and -3. We have 0, -2. We have -3, 0, 0, 2, and 5, 3. And let's go ahead and make our graph the best we can here. And there we go. Again, the line y equals x, if you graph that, it is a reflection across that line. And one question you'll always get with these is the inverse a function, right? So for this first one here, I'm just going to take a pin, and we're looking at the blue line. If you just take a pin and move it across, you'll see that it only hits the blue graph one time. So is number 3 a function? We would say yes, it's a function. For the next one, again, if you take this little line, now if you look at the blue graph, when it hits at more than one spot. Like here it hits twice, here it hits twice, and so on. So this is not a function because it does not pass the vertical line test. All right, determine if the following relations are inverses of each other. So this one's pretty easy to do. What you're going to do is you're going to take one of them and you're going to solve it for the inverse, okay? And once you prove that what the inverse is, you can verify it with the other one, see if they're the same or different. So if I find the inverse of this one and it comes out to look like this, then they're inverses. If I find the inverse of this and it doesn't match, then they're not inverses. So let's take a look here. So first off, we're going to change f of x to y. The direction said in order to prove that or to find the inverse, you switch x and y. So x equals 5y plus 7. Again, remind you, don't change any numbers, just swap the letters. So in order to solve y, we're going to subtract 7 from both sides first. And then we're going to divide each one individually by 5. Now, how did I know to divide it individually by 5? Because when I look at this one over here, they're both divisible by 5, not just the whole thing. So the inverse of y equals x over 5 is going to be 1/5 x, and then minus 7/5. So when I compare these two here, regardless of the g of x and the inverse of y, 1/5 x minus 7/5, you can see they're the exact same. So yes, they are inverses. If they weren't the same, if it was like a plus sign, then they would not be inverses. All right, let's take a look at number 6. So for number 6, it really doesn't matter which one you choose. Don't let the plus or minus throw you off. Like if you just cover that up and you switch x and y, solve, it's the same thing. But I'm going to go and do number 6 here. The first one, y equals x minus 3 squared. So for this one, I'm going to switch x and y. All right, and now we're going to solve it. So first thing I do to solve for y is I get rid of the square by taking the square root. When we do a square root, don't forget to put plus or minus. So we have plus or minus the square root of x equals y minus 3. We add the 3 to the other side. Now be careful here. It does not go inside of the square root because it's on the outside. So plus or minus the square root of x plus 3. So when I compare these two, the difference is this plus 3 is on the outside here, and this plus 3 is on the inside, so they are not inverses. So no, they are not inverses there. All right, let me go ahead and keep going. All right, now from this one here, it just says graph each equation and its inverse, include the line y equals x, determine if the function is, if the inverse is a function. So there's kind of a lot of ways to do this. You're going to graph these lines or quadratics, and then you're going to see whether they're a function or not. So for this first one, I'm just going to automatically draw the line y equals x. And I'll do that on the second one as well. All right, so for this first one here, y equals 5x, just remember that 5 is your slope and that this is your y-intercept, and you can see the y-intercept is pretty much 0. So we're going to plot the point 0, and my slope is 5 over 1, so we go up 5, 1, 2, 3, 4, 5, and right 1. Can't go up any further, so I go backwards, down 5, and left 1. I'm going to go to make my graph here. So I just use the y-intercept and slope to graph it. You can also make a table if you'd like. Now, to find the inverse, there's two ways, because it never says to solve for the inverse. It says just to graph it. So the first way you could do it is if you really wanted to, you could take the equation like y equals 5x, and you could find the inverse, right? So we switch x and y, and then we could divide both sides by 5, and we see that y is equal to 1/5 of x, so the inverse is 1/5 x. Now, that's one way to do it. The second way you could have done it is you could have just taken the points given to you. So given, we know this is -1, -5. We could have made that -5, -1. And then this was 0, 0, which when you swap x and y, it's still 0, 0. And this 1, 5 becomes 5, 1. So if I were to plot these, it'd be -5, 1, 2, 3, 4, 5, -1, 0, 0, and then 5, 1. So let me go and graph this. And there you go. Now, if you were to use this equation here, the y-intercept is 0. My slope is up 1, right 5. So up 1, 1, 2, 3, 4, 5. Down 1, and then 1, 2, 3, 4, 5. So you see they actually match up to be the same, regardless of whether you switch x and y or you solve for the inverse and graph it. Now, to prove that whether it's a function or not, vertical line test. So I just take this and I move it across. Notice the purple line is only touched once every single time. So is it a function? Yes, it is. All right, for number 8, we'll go ahead and graph this. So this is my y-intercept. So I begin at -4. 1, 2, 3, 4. This is my slope. So let me put it over 1, so 2 over 1. So from this point, we go up 2, right 1, up 2, right 1, up 2, right 1, and then we just keep going. Fill up the whole page, down 2, left 1, make our graph. Now at this point here, really it's up to you. Do you want to make a table, or did you want to just refine the inverse and graph it? That's your choice. Here I'm just going to make a table, and I'm going to go straight to the inverse table. So this point right here is -1, -1, 2, 3, 4, 5, 6. So -1, -6 becomes -6, -1. 0, 1, 2, 3, 4. So 0, -4 becomes -4, 0. 1, -2 becomes -2, 1. 2, 0 becomes 0, 2. 3, 2 becomes 2, 3. So notice as I say it, I just flip them. Then we have 1, 2, 3, 4. 1, 2, 3. So 4, 3 becomes 3, 4. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5, 6 becomes 6, 5. All right, from here I'm just going to graph these. Hopefully I counted that right. We'll find out. Let's see. So -6, 1, 2, 3, 4, 5, 6, -1, -4, 0, -2, positive 1, 0, 2, 2, 3. Let's take a look at this one real quick. So this was 1, 2, 3, 1, 2, so 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So this should have been 4, 4. Sorry about that. Good thing I caught that mistake. So 4, 4 should be there. And then 6. And then 1, 2, 3, 4, 5. All right, let's go and make our graph the best we can here. All right, and there is our graph. So we can see the inverses right there. So is this one a function, the purple line? When I draw my line through it, vertical line test, it only hits once every time. So again, yes, it is. So if you kind of see the pattern with a linear line, unless it's a vertical line, it's always going to be a function. Okay, let's take a look at number 9. So y equals negative 3x plus 6. So again, we're going to graph our line y equals x. We're going to graph this first one. So this is going to be y-intercept, which is at positive 6. 2, 3, 4, 5, 6. My slope is going to be negative 3 over 1. So from here we go down 3, right 1, down 3, right 1, down 3, right 1, 1, 2, 3. All right, so there's our original graph. Now for the inverse. So we have 0, 1, 2, 3, 4, 5, 6. So 0, 0, 6 becomes 6, 0. 1, 3 becomes 3, 1. 2, 0 becomes 0, 2. 3, negative 3 becomes negative 3, positive 3. Then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, 6 becomes 6, 4. All right, so let's go ahead and do 6, 0. 6, 0, and this is going to be negative 6. 3, 1, 1, 2, 3, 1, 0, 2, negative 3, 1, 2, 3, positive 3, negative 6, 4, 5, 6, and positive 4, 1, 2, 3, 4. Let's go ahead and make our line. And again, there's our inverse. And you can see vertical line test only hits once, so it's a linear line, so yes, it is a function. Now we're down to the last one. Okay, so for the last one, again, y equals x, the line is supposed to reflect over. And then here, x squared plus 2. So let's go ahead and make a table with this. This one, you can do transformations and stuff, but let's just use the basic points. So negative 2, negative 1, 0, 1, and 2. So right here, we're going to take negative 2 squared plus 2. So 4 plus 2 is 6. Now negative 1 squared plus 2. Negative 1 squared is 1. 1 plus 2 is 3. 0 squared is 0. Plus 2 is 2. 1 squared plus 2 is 1 plus 2 is 3. And then we can do 2 squared, which is 4, plus 2 is 6. Okay, so let's go ahead and graph this. So we have 0, 2. 1, 3. Negative 1, 3. 2, 6. 4, 5, 6. And 4, 5, 6. And here is our graph. Now for the inverse, I'm just going to take that table I just made and flip the x and y, swap them. So 6, 3, 2, 3, 6. Negative 2, negative 1, 0, 1, and 2. 1, 2, 3, 4, 5, 6. Negative 2. 3, negative 1. 2, 0. 3, 1. 6, 2. Make our graph the best we can. Now, for this one here, if you do a vertical line test, you'll notice at this point it hits twice. Twice, 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 twice. So this is a function. No, it is not. All right, now really quickly, how could I make this sideways parabola function? Well, one thing I could do is called adding a restriction, right? In the original one, I could have said y is equal to x squared plus 2. If like x was greater than 0 or if x was less than 0, because that would cut off half the graph. So when I graph the transformation, like I would cut off this top part and then it would become a function. But let's leave it like that for now.